Hello everyone, welcome back to Diksha Karnataka YouTube channel. So as promised, I am here with the recorded lecture for Chakravyuh wave optics. Okay, whatever doubts, comments that you have, you can mention in the live comments. I am live with the video. Okay, but I am not live. I am not doing this lecture live. It is already recorded by the time you are seeing it. But I am personally present with you. You can mention whatever doubts you have in the comment. I will answer them. Right, so today is Sunday, and as you know that we will not be able to complete all the Chakravyuh series if we do all the lectures live. So some of the lectures we have decided to go on recorded mode. So wave optics is a chapter that I think in recorded mode also it will be very fine for you. So we will start without any delay with the question. First question is very simple. Wave theory of light is proposed by Isaac Newton, Christian Huygens, Foucault or Snell. Okay, so it is Christian Huygens, neither Foucault nor Newton. Okay, first person who proposed the wave theory of light is Huygens. Newton proposed the corpuscular theory of light, that is particle theory of light, which was completely different than Einstein's wave nature of light, particle nature of light. But anyway, first was Christian Huygens. Now next question, according to Huygens principle, the speed of the secondary wavelets is. Okay, so this is also very common question. So according to Huygens principle, the speed of the secondary wavelets is same as that of the wave. Okay, not twice, not zero, not infinite, it is same as the wave. Now let's move on to the next question. To observe sustained interference pattern on a screen placed at a suitable distance in Young's double slit experiment, which of the following conditions are necessary? So what are all the conditions that is necessary to observe sustained interference? Sustained interference means interference pattern will be visible for a long time. It will not just appear and then disappear suddenly. Okay, what are all the conditions? Sources of light should be coherent. This is a compulsory condition. Okay, sources of light should be narrow. This is also in compulsory condition. Sources of light should be very close. This is even though not a compulsory condition, but it is given for a if they are very close, you will get a longer duration, you will get a very sharp interference pattern. So this is not necessary, but to observe a sharp interference pattern, this condition is important. But here we are only talking about sustained interference. So basically both 1 and 2 are the necessary condition. Third one is a good to have but not necessary. Okay, so there is a difference between good to have and not necessary, right? So now let's move on to the next question. Two light sources are said to be coherent when both sources of light emit light of same amplitude and phase, same intensity and wavelength, the same speed, the same wavelength and constant phase difference. So coherent means they must be of the same wavelength, okay, or very close to same wavelength. Okay, slight difference is okay, but not maybe 1 nanometer is okay, 2 nanometer is okay, but not super different. Okay, but they has to maintain a constant phase. Okay, that is very, very important. So same wavelength and constant phase difference is very, very important. Now let's move on to the next question. In Young's double slit experiment with the monochromatic light, how is fringe width affected if the screen is moved closer to the slits? Okay, so how if you move the screen closer to the shape, there is a relation beta, that is fringe width, which is basically given by lambda d by d. Okay, so here d is the size of the distance between the screen and the slits. Okay, the small d is the distance between the slits. Suppose this is slit number 1, this is slit number 2, so the distance between the slits is small d, this is capital D, and lambda is the wavelength of the light used. So if you bring the screen closer to the slit, that means you are decreasing d. Decreasing d means fringe width will also decrease, so fringe width will decreases, right? So the relationship is directly proportional. So if you reduce d, fringe width will also reduce. Next question, what would be the resultant intensity at a point of destructive interference if there are two identical coherent waves of intensity I naught producing an interference pattern? So both of them are I naught. So what will be the resultant intensity? Resultant intensity will be 0. They will cancel each other, and in the point of constructive interference the intensity will be 4 I naught, right? So it will become 4 I naught, and at the point of destructive interference it will be I naught. Sorry, not I naught, it will be 0. My mistake. Next question. Obviously if you are preparing for KCET exam, then definitely you have heard about our currently ongoing Abhyas KCET test series. You can enroll at the given link, and absolutely for free you will get 4 test paper which is already live in our portal. Only thing that you have to do, you have to go down in the link below, register yourself for absolutely free. If you want to purchase it right now, there is a good offer going on. First of all, entire course fee is 1498, and if you add only 1 extra rupees, you will get your PU2 test series that we have already launched. It is almost completed. You will get all the question papers, you will get all the solutions to this question papers. So everything you will get only for absolutely nothing price, ₹1. So 1499 you will get Abhyas KCET test series. First four test series are actually free. 31 tests are paid. 31 tests will start from 17th of March when your PU board exams are over. Since then it will be starting, and you will get 31 paid test series. The price for this was 3000, but after a lot of requesting we have managed to bring down the price to 1498, and with 1 rupee if you purchase it right now, you will get the PU test series as well. So your PU test preparation will be over, your KCET preparation will also be taken care by us. So don't miss out on the opportunity. You can use the link below and check all the details there in our website. Let's move on to the questions now. Diffraction effect is exhibited by only sound wave, only light wave, only matter wave, all types of waves. So diffraction is a property of waves. So all types of waves basically shows diffraction. Okay, it does not matter sound wave or light wave or matter wave. All type, if it is a wave, it will show diffraction. Now next question. So in a single slit diffraction experiment, the width of the slit is made double of its original width. Then the central maximum of the diffraction pattern will become. So we know that for a single slit diffraction pattern, the width is basically proportional to lambda d by a, where a is the slit width, right? Now if you double the slit width, okay, the existing central width of the central band will be reduced to half. So what will happen if you make it double? So it will become lambda d by 2a. So that means it is basically half of the value. So suppose this is the angular separation theta. Now it will be basically theta by 2. So the angular separation will be halved, but the intensity of the light will be doubled. Okay, so sorry, not doubled, it will be 4 times. So it will be narrower, but it will also be brighter. Okay, so answer will be narrower and brighter. Okay, so if you reduce the slit width, band increases, the central band increases. If you increase the slit, then central band decreases, but it becomes brighter. So narrower and brighter is the answer. Sorry, I have made the calculation in the next slide. Anyway, what is the cause of diffraction? Okay, interference of primary wavelet, interference of secondary wavelet, reflection of the primary wavelet, reflection of the secondary wavelet. Okay, so the cause of diffraction is not well defined. Some people say it's it is basically a type of interference, obviously, and obviously not the primary wavelets. From the given option, interference of the secondary wavelet is only possible answer from the given option. It is not reflection. Okay, bending of light would be more appropriate. Okay. So basically when the light is traveling across a sharp edge, suppose this is a sharp edge, light is traveling along this. Okay, at this sharp edge what happens is that this light is basically this is a source of secondary wavelets. From here light can emanate in all the possible directions. So you can say that if there are two slits like this, two sharp edges like this, two blade, suppose that, then here also this will be source of secondary wavelets, so they will interfere, and because of this interference you will observe a diffraction pattern. So you can say in another word, it is basically interference of secondary wavelets. Okay, very careful, not primary wavelets, they do not interfere directly. Okay, which of the following phenomena confirms that transverse nature of waves? Okay, light waves. So transverse nature can only be determined by polarization of light. Okay, polarization of light can only say that, okay, because electric field and magnetic field, they are perpendicular to each other, and the light that is traveling, it is perpendicular to both of them. So this is electric field, this is magnetic field, and this is the light which is propagating. So that is why it is called transverse wave. During the polarization, okay, all the other components are curtailed, only particular direction, electric field and magnetic field are allowed to pass. Okay, we generally represent light with only electric field. Magnetic field is very weak, but it is required, so we generally do not show the magnetic field. So if you have seen the polarization like this, that means it is only the electric field. Okay, these are all the lines that we show are electric field lines only. Okay, magnetic field lines are not shown. It is understood that magnetic field lines is mutually perpendicular direction, right? So it is only the polarization of light that proves that light wave is a transverse wave. Next, statement 1, wavefront obtained from light emitted by a point source in an isotropic medium are always spherical. Okay, statement 2, speed of light in an isotropic medium is constant. So wavefronts obtained from light emitted by a point source in an isotropic medium are always spherical. So basically, what is the meaning of isotropic medium? Isotropic medium means the medium where light travels with same speed in all direction. Okay, so that is why the light traveling in a same direction, all direction, okay, it will give you a spherical wavefront. If the speed is not same in the medium, then light will suppose in this direction light will travel faster, so it will not be a spherical wavefront, it will be something like this. Okay, so because light is traveling with the same speed, it is increasing with the equal radius after some time. Okay, so that is why it is the reason. So statement 1 and statement 2 both are correct, and statement 2 is the correct explanation for reason 1. So both statements are true and statement 2 is the correct explanation. That is why option A is the correct. So you have to understand that if the speed was not same, then it would not be a spherical wavefront. Obviously, in a homogeneous medium, homogeneous and isotropic medium, it is definitely speed of light is same in all direction. Okay. Next question, statement 1, interference is not observed if two coherent slits are broad. Okay, the broad source is equivalent to many narrow slit sources. Yes, so what happens is if the source is broad, that is wavelength, to observe interference, the slit width must be of the order of the wavelength. If it is too big, then multiple waves can escape through that area, and what will happen, you can consider them to be multiple slits, and multiple interference will occur, and one will occur on the above top of another. So basically you will see an equally illuminated plate, you will not see the proper interference pattern. So to observe interference, it is necessary that the slits are narrow. So we said that in the sustained interference example also, we said that the slit should be narrow, but distance does not matter between the slits. Distance is a good condition, but not a necessary condition. Okay, the broad source is equivalent to many narrow slits sources. So both are correct, and obviously it is the correct explanation for statement 1. Right, so again option A is the correct answer for this question. Next question, another statement based question. When a thin transparent sheet is placed in front of both the slits of Young's experiment, the fringe width will remain the same. In Young's experiment, the fringe width is directly proportional to the wavelength of the source. Okay, so fringe width, it is directly proportional to the wavelength of the source. It is also that transparent sheet, if you place transparent sheet in front of both the slits, okay, the fringe width remains the same, okay, because what is happening when you are placing, there used to be a theory part is not there for this question anyway. So if you place a sheet on one of the slits, what happens is that you are basically increasing the path difference for this thing, okay. So you are basically changing the path difference, and based on the changed path difference, the condition of interference will change, okay. So and you will see a different order of the fringe, so central bright fringe will shift, okay. And here also, if you place in both cases, okay, the it does not matter that both slits, it will remain the same, because both of them are equally delayed, and in Young's double slit experiment, the fringe width is directly proportional to the wavelength of the source. Fringe width in both cases will remain same because it is independent on the path difference. It is independent on the path difference, so both statements 1 and 2 is correct, and 2 is the correct explanation of the assertion. This is also option A. Be careful, even if you place one sheet on in one of the plates, okay, the fringe width will remain same. Fringe width is independent on whether you are placing a sheet or not. As long as light is allowed to travel, okay, fringe width will remain same. Only thing that will happen, if you place one sheet on the one of the slits, what will happen, that path difference will change, okay. So path difference will be changing, so the central fringe will be shifted by some amount, that you have to calculate, okay. That you can calculate, and you can find that theory part is no longer part of the syllabus, but this is an easy concept, okay. This is correct because both fringe width is basically independent of the path difference. Next is, a beam of unpolarized light of intensity I0 is passed through a pair of Polaroids. Their pass axis inclined at an angle of theta. The intensity of the emergent light is equals to. So first, unpolarized light is intensity I0, okay, and how many Polaroids it is passing through? It is passing through 2 Polaroids, okay. First Polaroid, say like this, second Polaroid is like this, so the angle between their pass axis is theta. So when an unpolarized light of intensity I0 enters a Polaroid, first Polaroid, after the polarization happens, now it is polarized. This is unpolarized light, this is a polarized light, so the intensity of this will be directly I0 by 2. I explained it multiple times. Now when it is passing through the second Polaroid, because the pass axis is theta, now it will be I0 by 2 cos square theta. That is Malus law, okay. This is Malus law, so it is I0 by 2 cos square theta. So option D is the correct answer, okay. Be careful, it is not I0 cos square theta. When it is unpolarized, it is passing through a first Polaroid, the intensity becomes directly half. Then onwards, as many Polaroids you keep, it will be always cos square theta of that angle, okay. Next question. To observe sustained interference, again I think it is the same question. Sources of light should be coherent, sources of light should be narrow, so option both A and B, okay. So orders are different, so A, B, this is C, and this is D. So both A and B is the answer for this question, okay. Now next, move on to the next question. According to Huygens principle, the speed of the secondary wavelets is twice that of the wave. 0 same as the wave, infinite it is same as the wave. We have seen this question before as well. When a point source of light is placed at a principal focus of a thin convex lens, the shape of the emergent wavefront is, very interesting. So you have a thin convex lens, and the light source is placed at the principal focus of the lens, right? So after it emerges out from the lens, it will basically become a parallel sources of light. So basically it's so the incident wavefront is spherical in nature, but the emergent wavelength are plane parallel to each other, okay. Plane wavefront, they will be parallel to each other, plane and parallel wavefronts, okay. So this is the thing, you have to draw the diagram to understand and answer this question. Very interesting question, okay. Next, the shape of the wavefront for light coming from a distant star. So a distant star means obviously, suppose in fact the sun can also be considered a distant star because it is not super close, unless we are living in Mercury, so we can say that light from a distant star are parallel, so the wavefronts will be plane as well. Okay, plane wavefront, again plane wavefront. Now next, the principle of superposition of wave applies whenever one source of light on a screen, one source of light moves across a screen, two or more sources of light illuminate the same point, two or more sources of light illuminate two different points. The answer is very simple and easy, obvious to guess. Two or more sources of light illuminate the same point, right? That is superposition. Superposition means has to be more than one and they should be falling on the same location, then only superposition can happen. Next is, we will have constructive interference if the path difference is basically path difference when it is integer multiple of lambda, we get constructive interference. The condition is delta x equals to n lambda. Okay, now next question. To observe diffraction, the size of the obstacle should be lambda by 2, where lambda is the wavelength, should be of the order of the wavelength, has no relation to the wavelength, should be much larger than the wavelength. To observe diffraction, as we said, the size of the obstacle should be of the order of the wavelength. So it will be very close to lambda, maybe 1 or 2 lambda or 3 lambda is fine, but it cannot be less than lambda. Obviously then the entire light will be blocked, but it should not be too large. The light, for example 1000 lambda, also not possible. 1 lambda, 2 lambda, 3 lambda is okay. Let's move on to the next. Two lights each of intensity I0 are used in Young's double slit experiment. The intensity of the interference maxima is, we have seen in case of interference minima it becomes 0, in case of maxima it becomes 4I0. Okay, it is 4I0, 4 times the intensity, right? So that average intensity remains the same. Now next question, when a compact disc is illuminated by a small source of white light, colored bands are observed. This is due to interference, scattering, reflection, diffraction. This is basically diffraction because the small edges in a CD, basically they are diffracting the light ray, and that's why we see colored band across the CD. Okay, if you see a CD and if you see it, you will see different colored bands on the diffraction. Different colors are diffracted by different amount, that's why those colors appear. Now, while both light and sound show wave character, diffraction is much harder to observe in light. This is because, so you can say that what is the diffraction in case of sound. So sound means you are standing near a wall, okay, the wall is not supposed complete, and you are shouting from this end of the wall, and someone is standing outside the other side of the wall, he can still listen to you. Why so? So basically, suppose this is the obstruction, you are standing somewhere here and you are shouting something towards your friend who is living on this side. Okay, this is one of the most common example, and when you are shouting, the sound waves are basically so large that it can easily pass over this obstacle and move to the other side of the wall. Okay, so that is the main reason. Because wavelength of the sound is so large, it can easily jump over that obstacle and go to the other side. But if you switch on a light, you will not able to send the light towards your friend. Okay, it is not easy to send the light signal towards your friend, but it is easy for you to send sound signal towards your friend. So why so? Because the wavelength of the light is far smaller. So light is far smaller wavelength, so it will be absorbed by this obstacle. But sound has a larger wavelength, very large wavelength, so it can easily cross over the wall and can go to the other side. So wavelength of light is far smaller, that is why diffraction, to observe diffraction in light is not so common. Okay, now which of the statements are correct with the reference to single slit diffraction pattern? Fringes are of unequal width. Okay, Fringes are of equal width, light energy is not conserved, intensities of all bright fringes are equal. So in case of single slit diffraction, intensity of the bright fringes are obviously different. Central fringe is maximum bright, and as you are moving away, the brightness falls rapidly, and after 2-3 fringes you don't observe in fact anything. Okay, so this is the central fringe, the brightness. This peak represents how bright it is. Okay, this is from the ground, this is suppose 0 brightness, so you can see this is the secondary maxima, this is the second order maxima. So maxima, as you moving away from the central fringe, the maxima decreases quickly, right? And fringe widths are also not the same. So fringe width for first central bright fringe is this much, second is this much, third is smaller. So all the fringes are of different width, and central maxima has the highest brightness. So fringes are of unequal width is the correct answer for this question. Let's move on. Diffraction effect is exhibited by only sound waves, light waves, only matter waves, all types of wave. We have seen this question as well. So this is also a repeated question. We cannot help it. We have collected questions from different sources, and all sources are giving the same questions. So there are some questions which are common. If unpolarized light of intensity I naught is passed through a Polaroid, then the intensity of the emergent light. Now here we have only one Polaroid, okay, and it is passing through that Polaroid. Intensity of the light, what will be the intensity of light? I already explained it. So first Polaroid, it will be exactly I naught by 2. It will be I naught by 2. So intensity of the light is I naught by 2. Next question. The phenomena of bending of light at the corners of an obstacle is called, so light bends because of diffraction. So nothing, not refraction, not interference, not polarization, it is diffraction. Okay, now if you have struggling to practice for your upcoming KCET 2025 exam, then Diksha is presenting you Abhyas KCET test series, where you will get 31 test, paid test and 4 free test, which is available right now in our portal. You have to use the link below, register yourself for absolutely free, and get the 4 free question paper available in our test series. When the test series goes live, you will get 31 paid test fully working in a online mode. You can test how much time it is taking for you to complete the test, how much score you are making, what is your leaderboard score. So everything you can check from this interface. So and everything you will get only for 1498. And if you pay 1 more rupees right now, you will get PU2 test series absolutely free of cost, or not free of cost, just for ₹1. So PU test series, which will be helpful for you to get good score in your PU exam. So that is also available for 1 rupee, and KCET Abhyas test series is for 1498 rupees. So total 1499 if you pay right now. You will be getting the 31 paid tests. It will start from 17th of March, after your PU board exams are over. Okay. So what you will get detailed video solutions for all the questions. You will get chapter wise one shot revision videos. You will get chapter wise insight for last 5 years KCET exam as well. So everything you need to get good rank in your KCET exam is here. So don't wait, purchase this right now, or at least register yourself for free, so that you can decide it later whether I want to purchase it or not. And obviously thumbs up this video, and obviously share this video with your friends. I'll be back with a new Chakravyuh lecture tomorrow evening as usual. Also morning, those who are watching my KCET master stroke series, I'll be live at 11 AM as well. So 11 AM and 6 PM both lives I'll be taking. So I will be see you tomorrow 11 AM. Till then, bye.